So my screen is visible to everyone, right?
Yes, sir.
Okay. So previously we have seen this FLs. So if anyone is having any doubt till this class, they can ask now. If anyone is having any doubt till this class, they can ask.
Hello.
Yes.
Sir, how can we convert an integer to a string? Like in Python, we can consider any integer as a string. How can we do that in C?
So you want to convert an integer to string or
Yes.
character. So wait. Kuldeep, can you hear me? Okay. Yeah, go ahead. What are you saying? How you can convert integer to string?
Yes, sir.
So you want to convert integer to string. You have to convert every digit to character and then store it somewhere. There is no direct conversion. There are libraries, but you are not allowed to use libraries.
Okay.
Yeah.
Sir, also, how can we find the length of a string?
Length of a string, just scan until you hit this null terminating condition. So a string is defined by number of characters and then it is terminated by a null character. So null character looks like this. Okay, let me write it. Yeah. So null character looks like this. So when you assign a character, char ch equals to something like this, then it is null character. Or you can directly write char ch equals to 0. So it will be converted to character. So the value of ASCII value of this null character is 0. You will read about ASCII value in maybe upcoming lectures. There it will be explained. So string is a collection of character terminated by this null character. So you read entire character, you scan until you hit this null character. So when you hit this null character, you can count up to that, and that will be the length of that string. Okay.
Okay, sir.
Yeah. So any other question so far? Okay. In last class, we have seen some operators. So there are kind of operators. First one is arithmetic, something like plus, minus, multiply, and then division. These are arithmetic operator. And then there is a logical as well as. So I will tell what is this as well as an or. So these two are logical operator. And then there is a comparison. For comparison, you have equals, double equals, greater than equals, less than equals, greater than, less than, and then there is a bitwise operator. For that you have and, or, and then not. So arithmetic is clear to everyone, you have seen it. Logical operators are those when you want, so this as well as is called and operator. So here whatever you are seeing, this double ampersand, this is called as well as. So it is stated like and this is called or operator. So when you write in some if condition, so let's say you are writing some if condition, something like if the a equals to, let's say, 5, you want to test whether a equals to 5 as well as b equals to 7. So this entire expression will be true. If both is true, then you will execute whatever you write at line number 16. Okay. So this is as well as, so if both a equals to 5, b equals to 7, if both are true, then line number 16 will be executed. So this is called logical and then there is this or. Here, if one of the condition is true, then GH, you will print this row. Okay.
Sir.
Yeah.
So like sort of an unrelated route, like in the if you added that curly brackets in the compound statement wala, like or like then sir, like it also works without adding that, but sometimes it breaks. Like why is that?
Okay, so curly braces added at line number 17 and this curly brace, right?
Yes, sir.
Okay, so when you have, that is very good question actually. When you have just one statement, so this see, in C, whatever you write in one line, not in one line actually. Okay, so whatever you write after the before this semicolon, it is called a statement. So after putting this if block, this is called if block, line number 15, this is if. So after putting if you have just one statement, then you can skip this curly braces. But if you have multiple statements, these are some garbage printing, but so if you have multiple statement like line number 16 and 17, so there are two statements. In that case, you have to put this curly braces. So by default, if there is no curly braces, even if you don't put curly braces, so what happens? So can someone tell what will be the output here? Okay, no, not someone. Let me ask. Okay. Akars Misra. Can you hear me? No. Ayush Gupta, can you hear me? No. So Akash Misra left. Can't unmute. Okay. So Meghna, can you hear me?
Yes.
Yeah. So here, as I've said that when you put curly braces, so if you have multiple statement, it will be executed when that condition is true. Okay. So let's say I'm not putting curly braces here. So how you will interpret this line number 15, 16, and 17? What will be the printing behavior of the output at the terminal?
16 will be printed, line 16 will be printed if the statement is true.
Okay.
And line 17 will be printed anyways because it is not in the if block.
Right. So that is the this behavior of not putting this curly braces. So even if you indent it something like this, but in C indentation is just for beautification. In Python it is necessary, but in C it is not necessary. So if you put if condition, so it will be treated like this. So by default, if or any construct, if or while or for loop, so any construct that you will see in C which have this curly open and close braces, so by default it will take one statement if you don't put this curly braces. If you put curly braces, then you want to include multiple statements to it. And one more thing you can write, so I've not covered nested if. Okay, so till this point everything is clear to everyone?
Yes.
If anyone is having any doubt, let me know.
Sir, in if statements, in the
Yes.
condition part, we cannot write double inequalities like we write while solving normal maths.
Double inequality, how? Okay.
Like
Okay.
a
Okay.
is
So
less
you,
than 5 and greater than 7.
no, you cannot
No,
like
no,
that.
opposite.
So yeah, so there should be only one this comparison operator. You cannot have two things. So if you want to check whether a is greater than 5 as well
We
as
have to
less
use
than
logical
10,
operators.
yeah, so you have to include this logical operators. But
Okay.
in mathematics, you can do something like this, right? A
Yes, sir, that is the
5 is less than or equals to a less than or equals to 10. In mathematics, you can write like this, but if you want to write it in C, you have to include this logical operator.
okay, sir.
Yeah. This was
Sir,
good
one more
question.
doubt.
Yeah.
If I define a variable and write an equation, like
Yeah.
have we seen the first lab?
Yes. Tell me.
So in the third question, we had to find the determinant of a parabolic equation,
Okay.
polynomial.
Okay.
If I define a variable like let's say d, which is
Hmm.
equal to b star b minus 4ac.
Okay.
Sir, so it wasn't working. Like it was giving me zero output every time. But then
It
I
should not.
defined it separately. Like I defined a variable e that is b star b, and then f that is 4ac, and then subtracted e and f. Then it worked. Why is
No.
it not working?
So you are saying that okay. So you have defined int some a and then b and c,
See, these are the
and
coefficients of the polynomial.
let's say result. So you have written result is equals to b
square minus
into
4.
b minus 4 into a into c, something like this, right?
Yes, sir.
B square
Yes.
minus 4 is a. So it will work.
But sir, it wasn't working. Like it was giving me zero output every time.
No, it cannot give zero output every time. So there could be problem with your declaration or the variable that you are using, or you
But
might
sir,
be
when I just
changing.
changed,
Yeah.
but when I changed the pattern of writing, like I defined b star b separately and 4ac separately, and then subtracted those two, then it was
Hmm.
working fine.
So you have defined like
Yeah,
this, and then 4ac separately, and then subtracted b2 minus 4ac.
subtracted. Yeah. Then it worked.
No. So can you send your code? I will
Yes,
check.
sir. But I don't think I have saved it. It was in Pruter lab, so
So it will be saved in your student this in your maybe in your scratchpad where you are practicing the
okay, sir.
lab
If I can
problem.
find it, I'll send it.
Yeah. And if you know the flow, just you can write it, right? You don't have to remember, right?
Okay,
So
sir.
you are saying that I've taken ABC as an input and then computed the result, right? So
Yes,
you
sir.
have done something like this. So write a
Yes,
program,
sir.
do like this, compile it on your local machine or router, and
Okay,
tell
sir.
me if it is producing every time zero
Okay.
as output.
I'll
Okay.
do that. Okay.
Yeah. Okay.
Sir, here also it's board mass is being followed, right? Like that.
Yeah. So multiplication will happen first.
Yeah.
So here there won't be any problem. So b square minus 4ac will be computed as you want b square minus 4ac to be computed, right?
Yes, sir.
Okay. So this logical operator is clear. Now comparison, as you have seen, I've compared less than equals, less than, greater than, equals, and then there is this bitwise operation. In bitwise, if you take to a variable a comma b, and then if I take, so if I write, so if I take input a comma b from user using a scanf, Now if we write result equals to A and B, so what it will do? It will do bitwise AND of A and B. So let's say, what do I mean by bitwise? So let's say A equals to 1010 and B equals to 0110. So you might know this, the bitwise AND. So if so, does anyone does not know the bitwise AND or not?
So
I
bit
think
no logical and or not is known, so but bitwise is not known.
Okay. So here A is so whatever you are saying. So I've written this A equals to 1010. So it is a binary number because it is just having 0 and 1. So this is called binary number, and B is also binary. So when I say C equals to A and B, so what will be the value of this C? So the value of C will be something like this. Let me define the AND logic first. So you might have heard these terms, I guess, gate and all this thing, but okay. So if bits are exactly equal, so AND will be, so AND of 1 and 1 would be 1, and other than any combination of 0 and 1, if you take AND, it will be 0. So if you take AND of 0 and 1, it will be 0. If you take AND of 1 and 0, it will be 0. If you take AND of 0 and 0, it will be 0. So this is the logic of bitwise AND operation. So this is called bit, 1 bit. So when both bit are like 1, then AND will produce 1. Otherwise, it will produce 0. Okay? Clear? This AND thing? Anyone?
Yes, sir.
Any
Basically, it's like
doubt?
the AND gate, right?
Yeah, it is AND gate. Yeah. So similar to so similarly, you can say this OR. So it is just like OR gate. So in OR, up to, so if one of the bit is 1, it will give 1. So in OR, if you write 1 or 1, so one bit is 1, so it will 1, 1 or 0, it will be 1, 0 or 1, it will be 1, but in case of 0 or 0, it will be 0. So just like gate. So if one of the bit in the operation is 1, then OR will produce 1. But in case of AND, both bit should be 1, then you will get 1 as output. So this is called bitwise AND logic. This is called logic AND logic, and then this is called OR logic. Okay. And NOT is just the complement of it. So when you say NOT, so if you put NOT of 1, it will produce 0. If you put NOT of 0, NOT of 0, it will produce 1. Okay. So up to here, any doubt? Anyone? And in AND logic, OR logic, NOT logic? Anyone? That is not trivial. Okay. So when A is 1010, B is 0110, and I'm taking bitwise AND. So what it will do, it will go bit by bit and apply the logic. So since I've written this AND, bitwise AND operator, so it will apply AND logic. So 1 and 0 would be 0, then 0 and 1 would be 0, and then 1, then 0. So this will be the output of C. Okay, but copy paste. But if you are using OR instead of AND, so what it will give? It will check whether one of the bit is 1 or not. So here it will produce 1, and then 1, then 1, then 0. So this is the result of A and B bitwise, and this is the result of A or B bitwise. So this AND, bitwise AND and bitwise OR is like binary operator, it needs two variable to be to do the operation, but this not thing is like one bit. This is unary operator. So this is called unary when you need just one operand to perform some operation. So if you write not of A, every bit of A will be flipped. So 1 will be 0, 0 will be 1, then 1 will be 0, and 0 will be 1. So that is the not of A. So what if the input is not a binary number? Yeah, then it will be converted to binary number. Implicitly, it will be converted to binary numbers. So you are saying that, so in C you cannot, so as I've said that only there are fixed data type, integer, character, float. There is no nothing, there is no data type called binary where you put number of ones or zero as a binary number. So for the binary, you have to enter it as a integer. And when you apply this A bitwise and B, here A and B both are int. So this is the responsibility of this AND operator. Whoever has written this the functionality of this AND operator in C, it is responsibility of that library or whatever function. It will convert those integer into binary and do the bitwise and produce the result in the C. And the C will also be the integer. It will not be the binary. Here I'm just for the sake of explanation, I've written it in binary format. But everything will be happening in the primitive data type, like integer, float, carry, char, something like that. Okay.
Sir?
Yeah.
Sir, is there a function to convert an integer input into binary, like in Python?
No. Why you want to have function for everything? You cannot write it. So let's say you want to, let's say, okay. So how you convert integer to binary? Do you know?
Sir, that method, that dividing by 2 again and again.
Yeah. So
We get out.
just divide. Yeah. So just write a loop. So let me cover the loop, and I will tell you how to convert those things. Okay. So don't depend that much on function or
like Python has something defined for it, so there might be that question.
But on behalf of you, someone else have done, right?
No, sir. Like other languages have it, so there might be.
No, in C there are like very few things. So that is why C is like faster. There are only the minimum set that is required to be added is added.
Okay, sir.
Yeah. So when I will cover this loop, I will cover the loop today. Then I will tell how to convert a number to decimal, binary, or anything, character, how to scan character, everything.
Okay.
Yeah. Any doubt so far? Okay, so up to this point, everything is clear. So I'm going to delete. If anyone is having any doubt, just let me know. So these are some operators. Then you can nest the if condition, something like this. You can perform nesting as well. So what do I mean by nesting? So let's say you want to check two variables. You want to check whether the range of A is from 5 to 10. If it is from 5 to 10, then you have to check whether the range of B is from 37 to 89. And then you print something. Or you do some computation, anything. Here also you can skip this parenthesis, because it is a kind of nesting, but ultimately it is just having one statement. So if you have done like many nesting, you can go at any level. So you can write one nesting here, and then again if, then again if, then again if. So you can nest. So this is called nesting. Okay. You can put this curly braces, as I've told, that if you have just one statement, then you don't need curly brace. It is optional. But if you have multiple statement or multiple computation, which is having multiple statement, then you have to put this curly braces. As you can see at line number 20, I have skipped the curly brace, but because it is just having one statement. So this is called nesting, and for good programming practice, we should only go up to 3 level of nesting, not more than that. So if you are going more than 3 level of nesting, then you might have to change your logic. So these are some standard programming practices. In worst case, you have to go up to 3 level of nesting. And as you know from the previous class, then we can write this else, and then put some condition there, and then perform nesting here, else if, and then some condition, then again else if, then some condition, and then here you can have nesting something like this, and then again nesting. So nesting will be overlapped with all the construct that I've told you, like if, else if, collection of else if, and then else, or if else, or if else, and there is a nesting of if else inside that if else. So these are nesting for the if and else statements. So any doubt so far related to nesting? Okay. So let's see what is called loop. Why do we need it? Without loop, we cannot do any actual computation. So let's say you have a number. You have to take input from user. So you write scanf, and then do like this number. And then let's say, as someone has pointed out how to convert a number. This is integer number. So you want to convert this integer number to binary. So you want to convert this integer number to binary. How you will do it? So there is this while loop construct. The while loop look like this. So there is this condition, and then if you have multiple statement, so same thing that I've told with if, you can also do with while. So if you have just one statement, then you can avoid this parenthesis. But if you have multiple statement, then you have to have it. Similar to if, you can have nested while loop, condition 2, and same thing will go. So then again while loop, then again while loop. So you can nest any number of time you want. So this is the syntax for while loop. So let me write an actual while loop. So let's say you want to convert an integer number to binary. You have taken number from the user, and let's say there is this variable temp. Store that number in that variable. Now if temp is greater than 0, then what you want to do? You want to do temp let's say you don't want to convert this number to binary, you want to extract digit of this number. That would be more simpler. So there is this integer number, it could be 12. So you want to print 1 and 2. Every single digit you want to extract. And after extracting, you want to do some computation on that digit, but let's skip that part. So what you want to do here, you want to extract a digit from the integer number. For that, how you will do it? You will write result equals to temp percentile 10. So what it will return? It will return a single digit. So let's say number is 12. So when you do 12 percentile 10, it will return 2. So you got the first digit. And then you have to get the second digit. For that, you have to update your temp variable, something like this. After getting digit, you can perform some computation. And then you have to update your temporary this variable. You have to update it by 10. So let's say, let me explain with an example. So let's say number is 123. So the number is 123. So temp will be 123 initially. So the value of result would be 3 when you do take modulo of modulo with 10. So first time, what will be the digit? It will be 3. Now it will go to line number 15, perform some computation. Then at line number 16, what will be the value of temp? So it will be 12, right? So when you divide by 10, it will be 12.3. But since temp is an integer, so when you divide 123 by 10, as you have seen in the previous class, that the result for this would be 12.3. But since the number is integer, so it will truncated, and the value that temp will be having will be 12. So after this division, 12 will be the next value of the temp. Now again, it will go and check whether temp is greater than 0. So yeah, it find that yeah, temp is greater than 0. So again, it will do the same thing. Now temp is 12. So when you do again the modulo with 10, you will get 2. Similarly, you do some computation, and then again the value of temp would be 1. Then again it will go at line number 13 to check the condition whether the temp is greater than 0. So it will find yes, temp is greater than 0. So again, you divide, you take modulo with 10, you will get 1. And then here, when you divide 1 by 10, actual value is 0.1, but since it is integer, so it will give 0. Okay, now temp is 0. So since the condition become false, you will exit the while loop. So we'll come at line number 18, and then next line will be executed. So this is how while loop is used. Yeah.
Sir, is floor division also valid? Floor division there in this, or it's not? Like double slash implies like you'll only get the integer.
Yes. There are floor division. I will tell. So after this, I will tell how to get the actual result, actual float result instead of int. Okay.
Oh, okay. Yes.
So any doubt? In this loop, any doubt? Anil Yadav, can you hear me?
Yes, sir.
Yeah, any doubt? Ask a question. No. Okay. Ritesh Verma. Can you hear me?
Yes, sir.
Any doubt?
No, sir.
Okay. So mute yourself. Okay. So this is how a loop is used. So this is called while loop. And this condition could be anything. Similar to if, it could have logical operator, it could have arithmetic, it could have bitwise, everything. But whatever you write, you have to be sure whether the return, whatever you are doing, is it should be some verifying thing. So it should return either true or false as a value, right? So can someone tell if I write 2 plus 3 here, what will happen? Yeah. So 2 plus 3. Yes, yes. So 2 plus 3 will be computed, and then it will return 5. As since 5 is not 0, so it will be infinite loop. But if I write 3 minus 3, it will return 0. So after any computation, when you get 0, it is treated as a false. And if it is if the value is non-zero, then it is treated as a true thing. So since in previous case, we are computing 2 plus 3, the value is 5, non-zero. So it was infinite loop. Infinite loops mean it will not terminate. So you will execute line number 14, 15, 16 infinitely. It will not terminate. But here, in case of 3 minus 3, the value will be 0. So it will be treated false. So nothing will be executed inside this while loop. It will this break the while loop because the value is 0. Okay. So similar to if, you can have any combination of this operators and numbers, variables, everything in this while condition. Okay. And you can nest to while loop. You can go as many level as possible, but don't go below 3 level. So these are some terminology for while loop. Okay. So now the person that is asking this, how to convert integer number to binary. So can you speak now?
Yes, sir.
Yeah. So tell me how to convert a number to binary then.
Sir,
What you will do
while
here?
loop, we can keep on dividing by 2, like the number modulo 2, and then
Okay.
print out the outputs one after the other.
Okay. Now,
Uh,
so what will be the condition here?
let me think.
So what will be the condition for the while loop?
Sir, I'll have to think. Like,
You have to think, I mean, temp is greater than 0. That is the universal condition, right? When you hit the 0 or greater than or equals to 0. What? Greater than or equals to 0. So like you have to divide by 2 until unless you get a 0, right?
Yeah.
But to get the digit, the binary digit, you have to take modulo with 2 instead of 10, right?
Yes, sir.
So you will take modulo with 2 and divide by 2 up to that point when you get 0, final 0, and then you exit. And then here you can print the binary output here, binary digit, binary single digit you can print.
Yes, sir.
So using this while loop, you can do string concatenation. So someone is having doubt how to concatenate to string. So using this while loop, you can concatenate to string. You can visit every single element in the array, and then you can perform anything with this loop. So loop and if is like very powerful thing. To do any actual thing, you need this loop and if construct. Yeah, so up to this point, any doubt, any question? No? Okay. So one more thing, you can write if some condition here as well, right? And then perform some nesting if you want to do. Else if, then again some condition. Inside that you can perform some nesting. Okay. And then finally else. Or you don't want to have else, that is also fine. So here you are using loop plus if else construct. And you can interchangeably use this thing. So you can write this, again, you can write some while loop inside this if with some condition. So everything is allowed. Every possible overlapping of if else or any two construct or any three construct or any number of construct is allowed. Okay. So okay. So this is called while. Now there is this second loop construct. It is called do while. So this is first loop. It's called while. This is called do while. So the syntax for do while is something like this. Do and then some statement. You can have a number of statements. Okay. And then you put while and then some condition. Semicolon. So this is the syntax for do while. So can anyone tell me why, what is the difference between this while and do while? Why do we need this do while, given that we have while?
So
Sir,
even if
do while loop checks the while condition after it executes the do part and then repeats it. So like do part will be executed once, even if the condition is false.
Right.
Whereas while checks the condition first.
Yes, yes, yes. So let's say in a software you want to initialize something, but not depending on some condition. You want to do some initialization globally, whether the condition is true or not. So you have to use this do while thing then. Or if you do not want to use do while, so what you can do in that case? Let's say don't want to use this do while construct. So how you will then program your logic with while loop?
We can write the do part separately.
Just
code
above the
do
while
part
loop.
separately
Yeah.
and then start as normal one.
Yes, yes, yes. But you have to take care which variables are going to change, and accordingly you have to write it. Okay.
Yes, sir.
Yeah. So what you can do, you can write the global initialization over here above while. This does not require any condition, and then inside while you will do the same thing. So actually, whatever you write here, let's say you write something here, the same replica will be there also inside while, right? So that is why do while is used, because it will reduce the line number, this line LOC, line of code. So we've written this, let's say 3 statements with do while. But if you do not use this do while, then you have to write six statement. So 3 above while and then 3 inside the while, and those 3 statements will be same, exactly same. So that is why do while is used to reduce this line of code. So this is the second. So up to here, any question, any doubt? So if you want to perform some computation after checking the condition, then you should use this while. But if you perform some computation before checking the condition and you perform the same computation again after checking the condition, then you should use this do while. And there is a other construct as well. I guess I will tell if time permit, but not. No. It is called for. I will tell, but let me tell you the float division. Okay. So for float division, you need to have float variable first. Okay. So let's say yeah. So can someone tell what will be the value of this result?
1.200000.
Okay. Anyone else? So why you have said this 1.200000?
So like, because isn't that the maximum number of like digits in like in float, like 6 तक जाता है शायद.
नहीं क्यों ले जाने की जरूरत है? 1.2 is like far more less space taking than 1.200000. It does not add any meaning, right? So everything should be as minimum as possible in programming. So 1.2 will be printed, not 1.200000. Okay.
Okay. Yes.
Yeah. So, and does anyone differ whether the value of result would be 1.2 or not?
Sir, I think it will be 1.
It will be 1. Okay. Why?
Sir, because 12 and 10 are integers, so it should give an integer.
Right. So internally, how this this division operation performed. So when you perform some operation, some binary operation, what happens? It takes 2 operand, and the result will be stored in the upper storage class. So here since both are int, so the storage class that is going to store the result will be integer. So here you are storing the result, you are storing the final result here in the float. But since you have not, everything is integer, so the division will be only integer specific. So when 12 will be divided by 10, it will produce 1. Okay, not 1.2. But let's say you want to produce this 1.2 in this example, how you will do it?
Then we can, instead of 12 or 10, we can write 12.0 or 10.0.
Right. So you can do something like this. You can do both, or you can do 1, or anything else you can do.
So we can write float.
Right. You can do this explicit typecasting here. On 12, you can do this explicit typecasting. So before division, 12 will be converted to float. Okay. And since the float is having higher storage than this integer, so the result will be 1.2. So you can do same thing on 10 as well. It is not very strict rule that only do on the nominator part. So you can do here as well. Okay. So yes. So if you want to produce this float result, so you have to be sure whether your one of the operand is either float or you have converted it as a float. Okay. And the double thing is just like the storage wise, double will be like having more number of combinations, so it can go up to more number of this decimal places. So let's say if float is going like 6 decimal places after this point, then double can go up to 10 or 12, I guess. Okay.
Sir.
So yeah.
Sir, but while printing, I am getting like 1.200, that like 5 times 0.
So you are getting 1.20000. Yes.
Yes, sir.
Okay. So you have printed percentage F.
Yes, sir.
Okay. So sometime it does, sometime it does not. So it's like compiler dependent thing. Okay.
Okay. Yes, sir.
Yeah. Sometime it terminate all the zeros, sometime it does not terminate. So it's like, okay. So up to here, any doubt? So this is called float division. That is how you perform this floating point division. Okay. So if you write similarly, if you write 2 by 3, the value would be 0, 0.00000. Okay. But if you do 2 by 3.0, then it will be 0. Whatever is the result. Okay. After dividing 2 with 3. So any doubt to here?
No, sir.
Okay. So if there is no doubt, then we can see the syntax for loop as well. So let's see. So in for loop, there are 3 things. One is initialization. You do some initialization, and then you terminate with semicolon. Then you do some condition checking. Then you terminate with semicolon. Then again you do something called updation. And then similarly, if you have only one statement to execute after for loop, then you can put the curly brace. You can avoid putting the curly braces, but if you have multiple statement, then you have to put the curly brace. Okay. So let's see what does this initialization, condition, and updation looks like in a real example. So everyone is able to see my screen, right? Comfortably. Okay. So let's say you have, there is this int I. This is called initialization. Everywhere the for loop is having I as an iterator. You can have iter, something like this, but it is like implicit universal that people use I in the for loop. So if I is, so this is called initialization. You do some initialization for the variable. Then you check for some condition. Let's say you want to go up to 10, and the updation, you want to update the I variable, and then you want to print the number. Printf %d. Okay. So what it will do, the control flow. So first it will execute this initialization, whatever you have written here. So it will be executed first, and then condition will be checked after that. Whatever condition you've written here. It could be combination of this, all the operators that I've discussed. So if the condition is true, then line number 40 will be executed. And then after finishing entire execution of this for loop, whatever you have written inside for loop, after finishing entire thing, finishing entire execution, whatever you've written, this I++ will be executed. So this updation thing will be executed only after executing the last statement in the for loop. So initialization execute only once. Condition checking execute every time. And then updation execute only at the end of the last statement. So the flow will be, this is just once, this initialization, then condition will be checked. Then you will come at line number 40, 41, 42. Then again you do updation. Then condition will be checked. Then again 40, 41, 42, then updation, then condition, then again. So that is how for loop is used. So whatever you write as a while loop, you can convert it to for loop. So can someone tell me the difference, like the logical difference of designing the for loop, given that you have while loop, or you have for loop and then you will design while loop?
Can you repeat the question?
Yeah, so let's say we are having this while loop, right? So we had this do while. So we have seen why do while is needed. Similarly, let's say you have while loop, you have written the while loop, do while loop. Now, why you want to give for loop construct to C programmer, given that you have while and do while? What is the benefit of giving for loop as a C construct?
Sir, like when we know the amount of times we have to repeat the process, but not the final condition that we have to satisfy,
Okay.
that time we can use for loop.
When you know the amount of time, so here also you know amount of time, right? In the while loop. So you can say how many times it will execute, right?
So in while loop, we only have to enter the final condition.
No, this is not final condition. This will be checked after before entering in the while loop. Every time it will be checked, right? Something like for loop. So I've written here the number I is less than 10. I can have an integer n, right? I can have integer n, take input n from the user, and I can execute this for loop variable number of time, depending upon the value of n, right? Similarly, I can do the same thing in the while loop, right? I can have temp as n, and then I will decrement temp, and then I will check whether the value of temp is greater than 0. So every time it will be checked, right?
Yes, sir.
Sir, I think any program, any code that we write in for loop, we can write it in while loop also.
Yeah, you can do. I just said that whatever you write as a do while, you can write it as a while. But I was asking about the positive or negative or the benefit of giving for loop as a construct. Is it like okay ठीक है अभी while अच्छा नहीं दिख रहा है तो एक for loop भी दे देते हैं, ऐसा कुछ?
प्रोग्राम थोड़ा छोटा दिखेगा.
Okay, any other? So this for loop is looking nicer than this
Yes,
while
sir.
loop.
Yes, sir. In
Yes.
one line only we can see everything, that initialization only or kahan tak
Right.
ko increment hoga,
Right,
everything is
right.
in one line. And do while
Right.
and while and do while we need to read the full code and where is
Yeah.
incrementation written. I do that
Yeah,
all.
so yes, so beautification and simplicity matters. So in for loop, you can see entire thing in one this bracket, but in while loop you cannot see. You have to see whether what is your decrement or whatever your update condition. So this temp is equals to temp by 2 is your update condition, right? You have to see whether you have written it. Okay, and you have to write it maybe at the last line. But for loop provide you. For loop says whatever you write here, it will be executed in the last. and it is simpler because you have initialization here, condition here, and updation here. And it is saying that initialization will be executed only once. This condition will be executed every time you want to enter in the for loop, and this updation will be executed at the last. So it is making sure that thing. So it looks nice, and it does nicer thing than this while loop.
And there is also one more thing that if we write plus plus I, then it will it will update initially only, not after completing the loop.
If you write plus plus here, it will update initially like this. So
Yes,
actually,
sir.
this plus plus is not covered, but let me cover it. I should have written something like this, because it is not covered. Let me cover it. So there are other operators as well. Post increment plus plus. So there are two kind of increment, post and pre. The sign would be plus plus. Similarly, for the decrement, we have minus minus. So let's see how it happens. So int a, okay, and then result. Let's say you have written result is equals to a plus plus. So what this post increment says, that it will be incremented after this line number 11. So the value of a will be incremented after line number 11. So let's say you have taken a, you have taken a as 10. Okay. So the value of result will be 10 only. But the value of a, if you write again, result is equals to a, it will be 11. So here a will be incremented after executing this entire statement. Whatever the analogy of this statement, it is saying that store the value of a in the result and then increment the value of a. This is the entire logic of the semantic of this entire statement. So it is saying that store the value of a into result and then increment the value of a by 1. So by increment, what I will do, I will just increment by 1. So if a is 10, so at line number 12, the value of result will be 10 and the value of a will be 11. So it is trivial that at line number 14, the value of result will be 11. Okay. But if you do pre-increment, so here the semantic is, it will say first increment the value of a by 1, then store the value of a in the result. So what will be the value of result? The result will be having, let's say you have not executed this line. So a was 10. Now it is saying that pre-increment. That means before applying this operation or assignment or anything, first increment the value of a. So the value of a will be 11 and the value of result will be 11. So that is the difference between pre-increment and post-increment. So it will increment by 1, but in case of pre, it will happen before applying any operation, any assignment. But in case of post, it will be applied after applying the assignment or any operation. And the value will be incremented by 1. So that is called pre-increment. Similarly, there is this thing, decrement. So this is called post-decrement. So it will decrement the value of a by 1. And the semantic is similar to what I've told for this post-increment. Similarly, we have this pre-decrement, and the semantic is exactly the same. Just that the value will be decremented by 1. So when you say here that I've written this I++, right? So I was saying that whatever you have written in the third block, it's not third block, you can say third statement of the for loop. So this is called updation. So here, whatever you have written, it will be executed after line number 48. So ultimately it looks like this. So I++ will be executed here. Okay. Whether you execute I++ or ++ I over here, does it make any difference? Anyone?
It does not, because like at the end of the day, I will be incremented by 1, but like if
We are not, yeah. We are not assigning anything. We are not doing any operation or anything. So whether I will increment the post in a post manner or pre manner, it does not make any difference, right?
Yes, sir.
Yes, sir. Got it.
So yeah, and it is like better to write I++ in the for loop instead of ++I. It does not look nice, right? But it looks nice. The flow is like left to right. The flow is good. But if you write this ++I, the flow is kind of broken. So yeah. So up to this point, and have you guys seen the lectures? So you are taking the advantage of this online thing, right? You're not seeing the lectures, I guess. Is it? No?
Yeah.
So you're not seeing the lecture?
Yes.
Okay. So ask any doubt related to lecture if you have. Otherwise, we will terminate this class. Or anything up to this point. Any crazy thing, weirdest thing, or anything that you have encountered so far in the programming world. No? Okay. So Kuldeep,
Yes, sir.
can you hear me?
Yes, sir.
Yeah, so any doubt?
No, sir.
Okay, so let's stop here. So thanks everyone.